Hey, today we're going to talk about a couple different things. We're going to talk about isotopes, we're going to talk about percent abundance, and we're going to do a little bit of a calculation problem regarding a simple little story problem. But before we begin, an isotope is an atom that has a different number of neutrons. It has the same number of protons, but it has a different number of neutrons. So what does that mean? Well, a way to draw an isotope is we may have, and this is the most common isotope, that our example of isotopes that we're going to be using, but we have carbon 12 and carbon 14. Like I said in a previous video, because this bottom number refers to the number of protons, this top number refers to the number, or the atomic mass. So protons, if you look here, it's the same in both of them. Because it's carbon, carbon has to have 6 protons. If it has anything other than 6, it is a different element completely. So this number has to be the same for carbon. This top number can be different, because as we've established, this is the number of protons, and we're going to do a little bit of a math problem to figure out our number of neutrons. So 12 is the atomic mass, 6 is the atomic number, or the number of protons. When I take 12 minus 6, that gives me my neutrons. So this carbon 12 has 6 neutrons, and carbon 14 has 8 neutrons. Now, there are naturally occurring isotopes. In other words, most of the carbon that we see in the universe is carbon 12. But some of it's carbon 14. There's also something called carbon 13, which has 7 neutrons. But basically, most of it exists in this form. In fact, it's something like 98%. It's a really, really high number. It's almost 100%. So what we really do when we want to figure out the average, or the atomic mass of something, and the atomic mass is the average mass, it's the weighted mass of all the naturally occurring isotopes. Again, atomic mass is the weighted mass of all the naturally occurring isotopes. So what does that mean? Well, here's an analogy. So here's my football team. It's a JV football team, but we got one big giant kid on this team. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 students that weigh 50 kilograms each. And we have one student that is top of the scales at 150 kilograms. So when we want to find out the average mass of a YCD JV football player, what we would do is we would take a weighted average. So when I look at this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total students. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9/10 of my football players are 50 kilograms. And if I count again, I'm not going to change the total number, so that's going to also be 10. And I have 1/10 of them are 150 kilograms. So the format for calculating the atomic mass is percent over 100 times the mass of A plus percent over 100 times the mass of B, and so on and so forth for everything. So what does it mean for this? So this is the percentage. In fact, 9 over 10 is the same thing as 90%. So I'm just going to do it like this. Times the mass, which is 50. Add it to percent times the mass. So 9, this is actually going to be 9 times 50 is 450 divided by 10. This is actually 45. Plus 1/10 of 150 is 15. So 45 plus 15 is equal to 60 kilograms. The average mass of a YCD JV football player is going to be 60 kilograms. If you notice, it was closer to 50, but this one large student brought the average up there. So let's show you another example. So we go through it. All right. We're going to look at Let's look at carbon 12 versus carbon 13. So carbon 12, it is a mass of 12. Carbon 13 is a mass of 13. And the abundance is 98%. And let's just say this is 2%. When we factor in carbon 14, it is a fraction of a percent. So I'm just going to show you how to set it up this way. Now again, I told you it's the percent over 100 times the mass of A plus percent over 100 times the mass of B, and so on and so forth. So it's going to be 98 over 100 times carbon 12 weighs 12 plus 2 over 100 times the mass of B, which is 13, equals 12.01 is really what it comes out to. You can do this calculation yourself. You're going to look at the practice problem. Okay? You're going to do this practice problem. But just to recap, we talked about percent abundance, and this is when we talk about percent abundance, it is how to figure out the atomic mass. Remember, the atomic mass is the weighted average of all the naturally occurring isotopes. Okay? Again, practice problems. Enjoy.